Hi, friends. Welcome back to Ryan's Routing Table. My name is Ryan, and we are doing yet another episode of Networking 101. This is episode 3. We're going to talk about IP addressing. Oh my gosh. Okay. Okay, sorry. I just have to. My rabbit's being very distracting. Look at this cute little face. Oh my gosh. Should we name the channel Networking with Rabbits? Maybe. I don't know. This is Mochi, everybody. He's so freaking cute. I just can't. Sorry. He hates this. So let's not waste any more time. Let's jump right in. So today's episode is about IP addressing, how every device gets an address. The big question is, why do devices need addresses in the first place? An IP address is like a postal address for a device. It tells the network exactly where to deliver the data. Every device that sends or receives data, a phone, a laptop, smart TV, router, it needs one. Without a unique address, a network has no way to know who the message is for. Imagine trying to mail a letter to your grandma and just writing her name on an envelope and sticking it in the post office box. The post office is going to be like, who's your grandma? I don't know this person. So that's like an IP address. There are 32 bits total in an IPv4 address. They are written as 4 numbers from 0 to 255. You can also see in the example here that the first 3 octets of this address are considered the network address, and the last octet we consider the host address. This is the most common setup for a network, the 3 octets being a network address, but it doesn't have to be. It can change, and we'll go over that in more detail in my next video. So when we refer to each part of the address being an octet, we say that because each part of the address is made up of 8 bits, and 8 bits written out in binary. As you can see, this is breaking down 1 octet in binary. So if you're not familiar with binary, this is the basic language of computing. Essentially, when you get down to the very nitty-gritty of all computing language, it boils down to ones and zeros, true or false, yes or no, on or off. Right? Without getting too deep in the weeds of binary, because that would honestly just be a video on its own, you can see here that 192 written out in binary is 11000000. If there's a 1 in the column, you add that number. And if there's a 0 in the column, then you skip that number. So right here, we have 128 with a 1, and we have 64 with a 1. So we take those 2 numbers and we add them together to get 192. In networking, it's good to know, but you won't have to do this by hand very often. But this is essential in understanding how the basics of networking works. So we have the network portion and we have the host portion. The network portion identifies which network a device belongs to. It is shared by every device on that network, and it's kind of like a street name. Whereas the host portion, that identifies a specific device. It is unique to that device on its network, and it's kind of like your house number. You can have many houses on the same street, but only your house is going to have that exact house number. Otherwise, how would the mail carrier know how to deliver this letter? Exactly where that split happens is decided by the subnet mask, and that is the topic of our next video. So stay tuned for that. There are 3 different ranges of private IP addresses, starting with 10.0.0.0 through 10.255.255.255. That is generally used for large private networks. Right in the middle here, you have 172.16.0.0 to 172.31255.255, generally used for medium private networks. In the smallest range, you have 192.168.0.0 to 192.168.255.255. If you were to go into your computer right now and check your IP address, I would bet $100 that it is in the 192.168 range. That is the most common one used in pretty much all home and small office networks. But everything outside of these ranges is a public IP address and is publicly routable on the internet. If you have an address in any of these private IP ranges, they are not able to be routed on the internet. So you might be wondering, well, how am I able to surf the internet on my phone if I have an IP address in the 192.168 range? Haha, great question. We're able to do this with a really awesome protocol called NAT, or Network Address Translation. This is sharing one public address amongst many devices. So essentially, you have your home devices that are all going to be in the 192.168. Let's say 1 range. Those are private addresses, right? But then the private devices in your home network send all their traffic to the router. The router uses NAT to translate your private address to a public address, to the single one public address that it has assigned from your ISP. And then that public address is used to route on the internet. NAT lets every device in the house use a private address, while the router shares one public address with the internet. There are 2 ways for a device to get an IP address, statically or dynamically. With dynamic, the address is going to be automatically assigned through a process called DHCP, Dynamic Host Control Protocol. A dynamic address is temporary, it's leased, and can change. Dynamic addressing is much easier to manage at scale and is used for most everyday devices. Static addressing is all manually configured. They're fixed, they never change on their own, and they're easy to find consistently. These would usually be assigned to servers, printers, network gear, stuff that you want to know what the address is on the network at all times, and you don't want to worry about it changing. So this video has been focusing on IPv4. There is also a different addressing scheme called IPv6. The issues that we have with IPv4 and the reason that we have public and private addressing and network address translation is that IPv4 being a 32-bit address, that only gives a possible 4.3 billion addresses total in the whole world. This addressing scheme was developed at the beginning of networking. So at the time, people thought, well, 4.3 billion devices, that's crazy. I mean, no one's ever going to have that many, right? They didn't really think ahead. That's why people have developed private IP addresses as well as network address translation to solve the issue of not having enough IP addresses to go around. IPv4, as I've said earlier, is expressed in dotted decimal. IPv6 is 128-bit addresses. It's effectively unlimited addresses. We could all be swimming in a vault of IPv6 addresses like Scrooge McDuck if we wanted to. And it's expressed in hexadecimal as well as separated by colons. So a quick recap, an IP address identifies a device the same way a postal address identifies a home. IPv4 is 32 bits, written as 4 octets in dotted decimal. Every address has a network portion and a host portion. Private ranges and NAT let a whole network share one public address. In the next episode, we'll be going over subnetting. We know every address has a network portion and a host portion. Next time, we learn exactly how that split works. Thank you all so much for joining me on this episode. I really appreciate you taking the time to watch these videos. Thank you, and I'll see you in the next one.